Hello, welcome guys. Today we are talking about the dew point temperature, and also we can say why there is some water on the surfaces. For example, when we are in the kitchen or when we are in the car, especially in the winter season. Let's start. The first example about it, please imagine it. You are in a kitchen and cooking something is here, and there is a door in here, and the door's glass is here. And for example, the outlet temperature is plus 2 centigrade, and this is outlet temperature, and indoor temperature is for example 9 centigrade degree. This is 9, and our problem is when we are starting the cooking or cooking milk or water or something, the water on the table after a time it will be start the saturated vapor. So after a time it will be saturated vapor and then vapor. And for example, this is a water on the table and you are cooking it, and then after a time it's starting saturation, and then after a time it is a vapor, and then like this. Then after a time this vapor, how can I say it, this vapor makes it the air, makes it the kitchen air kitchen, and then it moves towards the glass, and when it touch the glass surface, it starts to be water. We can see it when we are cooking something. So our question is why? This is very important, I think, because the surface temperature of the glasses is lower than the vapor temperature. For example, if water temperature is, for example, 100 centigrade degree, the surface temperature of the glasses is, for example, 9 degree respectively. Because of that, when the vapor touch the glass, it starts to be water. But this is there is a condition in there. This especially sorry, also I want to say we called it the dew point temperature. If the dew point temperature lower than the water vapor temperature, basically this vapor can be starts towards the water when it touching the glass surface. This is first example, and I want to explain the second example. Just a second. Yes, this one and this. The second example is, please imagine it, you are in a car like this and like this. Just imagine it, please. I know this is very bad sketch, but just imagine it. You are in a car and the season is winter season, and when you are getting in the car, you can see the water on the glass of the car, and when you are in the car also you can say uh, the water on the surface is indoor surface of glass. And after a time, when we are taking break and opposite, the waters on the glass starts to increase. Why? This is another question. Because when we are taking break, uh, we we add some air to car air, so our breath is higher than the indoor temperature of the car. And then please imagine it, this is glass of car, indoor glass, and when while the our breath arrive the surface of the glass, and when it touch it, it can be water vapor on the glass surface. So actually this is the very similar the previous example, because the surface of the glass is lower than our breath. I mean centigrade degree. For example, this is 10 centigrade degree, but maybe our breath 20 centigrade degree. So if the glass surface, just a second, if the glass surface lower than the dew point temperature of our breath, this means every molecule of our air starts move to water from the saturation, from the vapor. This is second example about it. Also, you can understand it. The key idea is the surface, just a second, the surface temperature, this can be glass or wall or something, must be lower than the dew point temperature of the air. Dew point air. If this condition, if there is this condition like this means every vapor can be transferred to water when it touching the surfaces. And I want to give another example about it. For example, when we are wake up early, for example, 5 a.m. and and for example when we are walking to bus station or to our job, we can see some water on the surfaces, for example, on the glass or on the wall. You can imagine it. There are a lot of surfaces around the street. I think every people saw that, saw like that example, and this means the air temperature, actually the air, while the air touching the surfaces, for example, glass surface or wall surface, it starts to transfer from the vapor to water. This is another example. I think you must, by the way, yes, thank you for watching.